Hello everyone and welcome to our second C++ intermediate lecture. So as usual, if you have any questions, ask them in the chat. This lecture is going to be mainly about C++ classes. So you need to know the basics of a class, so that a class can hold some different elements, different variables. So 1 second. Like this, and we can have public, and here we can have int x, for example, and double y, let's say. So yeah, so this is a class, and now we are going to start talking about some special functions that a class has, and that special functions help you to initialize the class, to create the class, and to destroy it when it's not needed anymore. So I'm going to start talking about constructors. So a constructor is a constructor. It is declared like this, so the name of the class, then some open and closed parentheses where you can write arguments if you want, but we are going to skip this for now. Then you have something called the body of the constructor, where you can say, for example, that x equals with 0 and y equals with 0.0. And what is this going to do? So whenever you create a new object of my class, this constructor is going to get called, and it's going to give a default value to x and to y of 0 and 0.0. Just so, for example, I have my class a, and if I do stdcout a.x and a.y, and also I'm going to write here stdcout constructor and a new line. So as you're going to see, first of all, this object is created and this constructor is called, so it outputs constructor, and it assigns x the value of 0 and y the value of 0 as well, as you can see here. Now, just a quick mention, I like to put this x and this y because it's a bit easier to read, and this is a pointer to the current instance of the class. So basically the current x, so a.x in our case, it's the same as just writing x, but it looks cleaner in my opinion. So yeah, and this is what's called a default constructor, and what that means is that it receives no parameters. So default constructor, no parameters, and I'm going to write here default constructor. And now what we can do is we can create multiple constructors. We can create some overloaded constructors. So for example, my class, and here we can give some arguments. We can give let's say an integer a and a double b. And now we can just say that this x equals with a and this y equals with b. And I'm going to say stdcout overload constructor. And now here what we can do is we can create another instance of this class, so my class b, and we can give it some arguments, so an integer and a double. So for example, we can say 4 and 8.4 or 8.5, let's say. And now what we can do is stdcout b.x and b.y. Okay, so what will this do? Well, basically here we call the default constructor that receives no arguments. This is the same as writing a with open and close parentheses. It's the same thing. And here we call the overloading constructor of B that receives an integer in the double. So this though. I'm going to run this, and as you can see, first of all the default constructor is being called, and a.x and a.y, each of these are being assigned a value of 0. And then my class of B is constructed with the overloading constructor, and b.x is assigned the value of 4 here because a is 4 for us, and b.y is 8.5. So as you can see, 4 and 8.5. And also one little thing that usually if you want to call this constant, so you want to make this constant, make sure that you don't change them accidentally. It's optional, yeah. And also one more thing that I can do is, and why I like to use this pointer, is that here we can name them x and y as well, and just have x and y. So this means that this x, so the x in the class, is given the value of the x here, the x in the function. This works well as well. So yeah, I'm going to leave this like this. So, and we can create as many constructors as we want, as long as their arguments are different. So I can call this copy constructor 1, overload constructor 1, sorry. Now I can create a constructor that receives only one argument, a constant integer x, and it's going to do this. 1 second, because okay. Okay, let's try this again. My class and constant int x, we have this x equals with x, and this y equals with 0.0. And as this out overload constructor 2, and here I said 1. I don't know what happened with this thing here. 1 second. Okay, I don't know, something weird, but okay. And let's make a new line, and now this, if we create, for example, we can create my class C with only one integer as an argument, so my class C of 8, and this is going to call the second overload constructor. As you can see here, called the second constructor, the second overloading constructor. Okay, so this is the basics that you can do with constructors, and I'm going to talk about one more thing, that is a member initializing list. So right now we assign the value inside the body of the constructor. However, what we can do is, I'm going to get rid of this from now, of this constructor and of this. And what we can do instead of this is we can create the constructor, my class, with no arguments, then a colon, and then we want to give x the default value of 0. So we are just going to write x and 0 here. Now we want to give y the default value of 0 as well, or 0.0. So we put a comma and y and 0.0. And now in the body of the constructor we won't write anything. So this does the same thing as this one. I mean almost the same thing. And then by SDC out, I will just put C and then line for simplicity, but I think you understand right now what happens. And now I can create this overloaded constructor. Let's say my class, let's say constant int, let's call it A, and constant double B, colon x, and here we put A, y, and here we put B, and the body of the constructor that is empty. And this does the same exact thing, so I'm going to write scene here as well, like this. Okay. And as you can see, these two constructors are getting called and they do the exact same thing as the ones above. However, there is one difference, that being that in here you initialize x and y with these values, while with this constructor you just assign this value to x after it was initialized with a random value. So this means if you have this as constant integer and constant double, these constructors are going to work. So with the member initializing this is going to work. And however, if instead of this you use the normal ones, or the ones where you just assign the value to x and to y, this is going to throw an error. Yes, as you can see. So because here basically x is initialized here, and here it's just assigned the values after it's being initialized, and this being a constant variable you can't modify it in here, and that's a problem that this member initializing list avoids. And it is also preferred to use the member initializing list because of this reason, and because it can be a little bit faster. I'm not entirely sure, but I think it can be a little bit faster. Just a tiny bit, doesn't really matter, but it's preferred to use the member initializing list. So yeah, so this is it with constructors for now. Now I'm going to move. I'm going to keep these ones and delete what's in here and delete what's in here. Also make this not constant. Okay, and now I'm going to talk about destructors. So as constructors have, and constructors basically create an object, like as you can see, destructors destroy it when it's not needed, and usually when it falls out of scope, but not always. So let's start with the beginning. If you declare a destructor in the same way that you declare a constructor, but with a tilde at the start, so write tilde, then my class. The destructor doesn't receive any arguments at all, and then you have the body of the destructor. Let's say std destructor in the new line. Now here, after we call these two constructors, what we are going to see is if we can run this. Yeah, 1 second. Okay. So as you can see, these two objects are being destructed. But when are they being destructed? Well, here if we do, for example, std hello and a new line, you are going to see that hello gets printed before the objects are destructed, as you can see here. So what does this mean? Well, this means that these objects are destructed when the program ends. Well, when their scope ends, and thus their scope ends outside of the main function. So here A and B fall out of scope. That means that they get destructed. And you can see this very easily in the following example. So if you create a scope inside the main scope, and we declare B inside here, then hello, and then std word, for example, in the new line. Well, what is going to happen here? A is going to fall out of scope here, so A falls out of scope. However, B falls out of scope right here, where its scope ends. So B falls out of scope. So that means that basically hello gets printed, then B gets destroyed here, so as you can see destructed, then word gets printed, and then A gets destructed, as you can see here. So yeah, you can do some more interesting stuff with destructors, but for now we are just going to stop here. Oh, and also one more thing that it's not going to be extremely useful for now, but later it's going to be useful. Objects are destroyed in the reverse order that they are created. So what do I mean by this? Let's just comment this out. And so this means that if we have my class A, my class B, and my class C, here first C gets destroyed, so C gets destroyed, then B gets destroyed, then A gets destroyed. So basically C, then B, then A. So in the reverse order that they were constructed. And this is going to be useful for later. Yeah. Now I'm going to talk a bit about copy constructors. And they are like the normal constructors. However, instead of receiving basically like a value that they can get by default, or let me just get rid of the destructor. And now a copy constructor is when you, for example, when you create my class A, let's say A with 6 and 2.4, then when you create my class B equals with A, and this is the same as B and A in here, it's the exact same thing. So yeah, so here basically you want to copy all the elements from A to B, and you do this using the copy constructor. And if you want to create one copy constructor, you can do my class, and then the syntax for it, one of the syntaxes, is constant, the name of the class, so constant my class, and then a reference, the object that you copy from, and a name. I'd like to put P, but it doesn't really matter. So here P, so in our case where B equals with A, P is A, and B is the current class that we are copying to. So this is a copy constructor. And what you do is this x equals with p dot x, and this y equals with p dot y. So this basically copies the member x from A to B, so from P to the current instance of the class, and it copies y in the same way. So now if we do stdcout b.x and b.y, we are going to get 6 and 2.4. Why don't you work? Repeat. Okay, just wait 1 second because I don't know what. Oh. Okay, so as you can see, b.x equals with 6 and b.y equals with 2.4, that as we said here. Okay, so, and there are 4 ways to create a copy constructor as defined by the C++ standard. So you can say constant my class. I'm going to list them below, even if they are not, you don't really care about them right now, about the other ways. But so you can have my class and constant my class and the reference and the name, for example P, and the body. But I'm going to ignore the body for now. You can have my class and without constant, just my class and the reference to P. And you can have my class and constant and the keyword volatile that I'm not going to explain now, because and you don't have to worry about it for now, but I just so can see it. So in my class and without constant, just my class volatile my class P. So these are, all of these are copy constructors as defined by the C++ standard. For now we are just going to use this first one, the normal one. And yeah, just so you know, this is how you can create them. And so yeah, now I'm going to talk a bit about something a bit kind of similar. That is the assignment operator. So the assignment operator does the exact same thing, so as the copy constructor, but it's not a constructor. So if we have, for example, my class C and then C equals with A, here we call the default constructor of C, and here we can call another constructor because C was already constructed. So here we just use the assignment operator, that's this equal here. And this means that C, all the elements from A are being copied to C. So in the same way you can do sd cout c.x and c.y. And now again, as you can see, everything is copied from A to C. The values are the same. But I'm going to talk a bit more about how this works a little bit later. Now this gets me to the next idea, that is the C++ compiler basically provides some default special functions, I would call them. So if we don't specify, so we can, for example, just leave a class like this without anything, just with its members, and we can still call that a default constructor, a copy constructor. We can still use the assignment operator, and we can still destroy them at the end of the program, even if we didn't declare anything. So this code should run perfectly fine. Yeah, it gives some random values because we haven't given a default value to this, but the idea is that the C++ compiler and the C++ basically gives some default constructors, destructors, copy constructors, and an assignment operator. And how this looks, basically the normal constructor that it gives is basically looks like this. So this is what the compiler provides, and the compiler provides this only if you don't write any kind of constructor. So if you leave the constructor blank. So this is its constructor, it's going to run, and you see a random value. But what you have to note is that if you create, for example, a constructor with some arguments in it, so int x and int a and double b, and here we have x of a and y of b, this is going to throw an error. And you may ask why it throws an error, because you already have the constructor. You can even have here like 4 and 7.2, and I'm going to comment this out for now. So I'm going to run this, and let me clear. Oh, also this seems to work actually. Okay, I didn't actually know that this would work. Okay, so yeah, but the idea is, the point here stands. So if we don't use this constructor and we rely on the default constructor being created by the compiler itself, it's not going to work. It's going to give an error because the compiler creates these like, I know, they are default but in a different way, I would say. But the compiler creates these default constructors and default special functions if there is no other function of the type. So if I create myself one constructor, the compiler is not going to create anything else. It's not going to create any other constructor. So that's why if I want to create this constructor, I also have to create the default constructor myself. So now I can do my class, and it will work fine. Okay, so yeah, and this applies to everything, not just constructors, to structures and copy constructors and the assignment operator as well. So now this is how the default constructor looks like. This is how the default destructor looks like. So it's basically like this. This is how the copy constructor provided by the compiler looks like. So my class and constant, my class and here name, and we just have we can also just do like x and p.x and y and p.y. So this should work. The copy constructor, yes. And now the assignment operator. One second. Like I'm going to explain what the assignment operator looks like and is what it is. So for now, just remember that this is how the compiler provides it. So you declare my class operator and the assignment operator. So let's say we basically want to overload what's called new overload an operator, and here we are going to write constant my class and p. And now, as I said, I'm not going to talk much about this right now because I'm going to teach it a little bit later. For now, just know that this is how it looks, and in here you have this x equals with p dot x and this y equals with p dot y, and here it returns the reference this pointer. This is because you have to return my class because it's a function type and you have to return my class, and this is a pointer to the class, so you basically dereference that pointer. And yeah, I'm going to explain this a little bit later more. Also, I forgot to mention, so I said that b equals with a here uses the copy constructor, while c equals with a uses the assignment operator. And why this happens is because here b is being constructed right here. So b equals with a or b a, this is the same thing. Here b is being constructed. However, here c uses the default constructor, and so then c can't use the default constructor again or the copy constructor again here, since it already uses the default one. So here it uses the assignment operator. That's basically the difference between them. So yeah. Okay, so now I'm going to talk a bit more about overloading the assignment operator. So first of all, I'm just going to write here an example. So my class operator. So when you want to overload any operator, you have to write operator here. Now, since I want to overload the assignment operator, I'm just going to put operator and then the assignment operator equal. And now this is going to receive an argument that is going to be another instance of my class. So I'm basically going to have constant my class and a reference to p. And what will this do? So what will the code inside this brackets will do? Well, if I have, for example, my class A, and then if I have my class B, then I can do B equals with A, as I shown before. And this, what B equals with A, what this assignment operator will do is declared here. And basically P is going to be A, so it's going to be the right operand. And then this pointer, so this pointer points to the left operand, that being B. And I can do, for example, let's say that I want to when I want to copy A to B, I don't actually want to just copy it. I want to increment, for, let's say, x by 1. So I want to say something like this, x, so this x is on the left of n, equals with p dot x plus 1. So this means that I'm going to copy, that when I'm going to copy this, x is going to be plus 1. And let's say that I want to subtract from y minus 0.3. So I can say this y equals with p dot y minus 0.3. And not because this is a function and it has to return my class, class. What I can do is I can just return this pointer, since this is a pointer to my class, and it can just dereference it. Okay, so now let me just write some quick constructors. So my class and x of 0 and y of 0.0, and my class constant int a and constant int b, xa, and here I have to put a double, not an int, xa and yb. Okay, and now if I do, for example, a and let's say 5 and 3.7, now I'm creating b, I'm assigning it the value of a, however I'm not actually assigning it the value of a or what is stored in a. I'm going to assign it like a bit modified as I wrote here. So I'm going to assign a.x plus 1 and a.y minus 0.3. So if I do that with this out b.x and b.y, this should output, as you can see, 5 plus 1. I set here p.x plus 1 and 3.7 minus 0.3, that's 3.4. So this is so like this you can basically just like you can manipulate the way that this operator works. Okay, so now I'm going to talk a bit about different ways to copy something, to copy an element to. So let me just delete this for now, and I'm going to leave it like this. And I'm going to talk about shallow and deep copying. So first of all, we are talking about shallow and deep copying when we deal with copying pointers and copying addresses to values. So I will make here an example. I will create a pointer. I'll make it private because I don't really need to access it, but like you can make it public as well if you want. And I'm going to create a pointer x in x. And now what I want to do is I want to make public and create some constructors. And now I'm going to make my class a default constructor that's going to create a new integer on the heap. So I want to do x equals with new int and semicolon. And I want to do an overloaded constructor with class constant int x, and I want to do x equals with x equals with new int of x, but I think I can put this x, this x. Just let me check if this actually works. And a semicolon. Okay, so this works. So this x equals with new int and this value of x. Actually, I'm going to use n, so you just don't. Okay, so here is the value of n that's written here. And now what I'm going to do is a copy constructor, and in this copy constructor I can copy in two different ways, and that is I can shallow copy or deep copy. And I'm going to show both of these now. So my class and the reference to P. And shallow copying basically means that you create another pointer that points to the same address as the original pointer. So I can do something like this x equals with t dot x, and one second I realized that I actually need I am pretty sure that I have to put this in public. One second. Actually, no, I don't have to make this public because it's inside the same class. Yeah, I forgot about that. So, okay, just don't worry about what I said before. Okay, so this basically copies the address that p.x points to this x. So, if I do my class a 5, and then I do my class b equals with a. Now, if I do sd cout and a.x and b.x, oh, x is a private member. Yeah, that's why I wanted to make it public. I can put everything public, so I can access it from outside the class itself. And as you can see, these two pointers, a.x and b.x, point to the same memory address of 145AE70. It doesn't include much, but now the idea is that so first of all, this is shallow copying, and this means that if I change, for example, a.x, let's dereference this, a.x equals with 7. Now if I try to output sdcout dereferencing a.x and dereferencing b.x, both of them are going to print out 7, because basically this memory, the value stored at this memory address was changed. So both of the pointers that point to it are going to update, basically. So because the value changed, and it doesn't matter that the pointers, because the two pointers point to the same value. And this is the problem with shallow copying. This is where deep copying comes into play. So deep copying, what deep copying does is, I'm going to comment this out, and I'm going to create my class constant my class p, and now instead of copying the pointer, it's the address that p.x points to, I'm going to create a new integer with the same value. So what I'm going to do is this x equals with new int, and new int with the value that dereferencing p.x to get. So this basically creates not a pointer to a different memory address with the same value. So now this will print out there are two different memory addresses, as you can see. This one is different than this one, and if you modify a.x or the value stored at a.x, the value stored at b.x doesn't modify. So if we have now, for example, b.x equals with 93, and this cout the value at a.x and b.x. Oh, by the way, so this is deep copying. As you can see, these two values are independent from one another. And replete. I forgot to close the bracket, I think. a.x, b.x. 35. What? Wait, I'm going to run it again. I think. Yeah, okay, so that it just had a hiccup. Okay, so as you can see, these two values can be modified independently from one another, and it basically works the same way for with assignment operator. So I can do an assignment operator, my class operator equal the assignment operator, constant my class in the reference to p, and now I can do this x equals with new int. And actually, if I use the assignment operator, it means that this new integer was already created here. So what I'm just doing is, if you dereference this x, if you dereference it, it is equal to p.x dereference. But I mean, this doesn't matter that much right now, and yeah. So if we do my class here, instead of using the copy constructor, we use the assignment operator. It should be equals with h, should be the exact same thing. Okay, one second, I forgot I have to return to this pointer, and yeah, so it works the exact same way with the assignment operator as well. So yeah, but what we care about right now is the copy constructor. And this thing, you should know when you should share a copy and when you should deep copy. I also have a link where you can see on Stack Overflow how some like illustrated pictures of how this looks in memory, and they're going to be in the lecture notes, and they're going to be in the chat as well. And now I'm going to use to just go there and show you it's on Stack Overflow. And so as you can see here, when you share a copy and when you share a clone, both the original and the cloned object point to the same referenced object, so the same value. And when you deep clone, each of the objects point to their own referenced and clone and reference clone. So the original object points to the referenced object, and the cloned object points to the referenced clone. So yeah, that's and at this link you can find a few more explanations if you didn't fully understand this. And yeah. Okay, so now I'm going to talk about operator overloading. So before I talked a bit about overloading the assignment operator, and now I'm going to explain a bit more what's happening and how you can overload almost any operator, such as the addition operator, the subtraction operator, the input and output operators, and everything. So basically, when you overload an operator has, let's say, the addition operator, it can, for example, if you have two integers, you can add them together, and this is like how it usually works. However, if you have two classes, but let's say my class A and B, you can't do A plus B because that's not, A and B are not two numbers, they are not, you can just add them together. It doesn't make any sense. So that's when operator overloading comes into play. So if you have, let's say, a class named box, because it's, or no, I can upload with a different example with time. Let's say that we have a class that is public, and here we have int hour and int minute. And where I'm going to do some default constructors for it. I'm not going to connect it very quickly, but and minute is 0, and time int h and int m, hour h and minute m. Okay, and now what if I have, let's say, time a that is like 6 hours and 57 minutes, or let's make it 47 minutes. And if I have time b that is 3 hours and let's say 29 minutes. Well, what if I want, for example, to add these times together? What if I want to do something like a plus b? Well, I can't do that since these are two classes, they are not just two numbers. However, I still want to add, like, you know, just to add the hours together. Well, I can overload the addition operator so it can actually do this. And I'm going to do it this way. So first of all, the addition operator is going to return another instance of the time class. Then you have to write off the operator keyword because you want to overload an operator. Then you add what operator you want to overload. I want to overload the addition operator. Then this will get, so this will get one argument that is the the second operand that we have. So the first one is this class that we are in right now, this instance of the class, and the second operator is going to be here. It's going to be a constant time class. Let's name it p. And now what I can do is I can say this hour plus equals with p dot hour. So we add p dot hour to this hour. Then this minute plus equals, 1 second, plus equals to p dot minute. Oops, I wrote here. Wait, minute and p dot hour I want to say. And here p dot minute. And now we also have to check if the minute is past 60. So if min is more or equal than 60, then we have to add to the hours here. And how we do this? With a little bit of math. So basically this hour is going to get incremented with this minute divided by 60. So if this minute equals 60, then 1 hour is added. And if this minute equals 130, let's say, then 2 hours are added, and etc. And then this minute will be the remainder of this minute modulo 60. So basically here we have the remainder of 60 minutes, and we add that to the hour. So now if I do, for example, SBC out a plus b, I have to do hour, and this is going to be, let's say, times c equals with a plus b. I have hour equals with c dot hour, and minutes, wait, hours and minutes is c dot min. And now, as you can see, oh yes, and we have to return this now, if I'm not mistaken. Return this, because as you can see here we have to return time, so return this and reference this pointer. Oh, never mind. Oh, okay, now it works. So And as you can see, we have 10 hours and 16 minutes. This is because 6 hours plus 3 hours equals 9 hours. Then 47 plus 29 equals 76. And 76 means 76 minutes. It means 1 hour and 16 minutes. And this gets added to this time C. So just 1 second. Return. Okay. And this is basically what operator overloading does, and this is why you should use it and when you should use it. And you don't have to overload only addition operator, you can overload different operators. And I have a link that I will post in the description as well, in the lecture notes as well. So I'm going to show it right now. It is on tutorials point, and it has all kinds of operator overloadings. So first of all, it talks a bit about function overloading. That is pretty easy. You can read it if you want, but we'll skip it for now. Now we get into operator overloading. And here they have an example with a box where again you overload the box operator, the addition operator for the class box, where it adds the box length, the box breadth, and the box height, and it returns box. And here you have a list of all the overloadable operators. And as you can see, you can overload addition, subtraction, and a lot of these. And there are a few operators that cannot be overloaded, that is the double colon. For example, when you use SDC out and use double colon, and these operators. But you don't care that much about this right now, so just remember that you can overload most of the operators that you want. And here they have examples for different types of operators. And for example, we overloaded a binary operator, that is the addition operator, like addition, subtraction, division, and also multiplication, but we didn't write. You have input-output operators, for example, and you can see you have to use a keyword here that we are going to learn in a bit. You want to overload this operator, the output and the input operator, and so yeah, basically here you have examples of how you can do this, and you can look through them. They are pretty helpful, I would say, all of these and everything. And okay, so now I'm going to talk about templates. And templates are a topic that scares a lot of people off because they can be very complicated. And right now I'm only going to teach you guys like the basics and what they are and what they do. So, well, first of all, templates are when you use templates, it's basically called metaprogramming, and that means that you are basically writing code to make the compiler write other code by itself. And I'm going to explain this, and I'm going to explain what this means a little bit later. Right now, let me just show you an example of what template is. So you have to write template, and then some open and close the, I don't know how these are called, this less and greater signs. And in here, for this example, I'm going to type type name, T. And T is a name, so here I could write if I want, I don't know, name or anything. So type name T. And what does this do? Well, now this T can be something like integer or char or float or double. It can basically be a data type. And now I can do T, they can give a name, text. So what does this actually mean? So for example, I can create my class, and I have to specify between these brackets, or however they are called. I will call them brackets. I can say, for example, int. Now I create int a, and what this will do, it will create this x as an integer. So it will create, I can say now a.x equals with 5, and I can actually this cout a.x plus 1, and it will output 6. So as you can see, this tx is actually an integer x, because I wrote here my class of int. So this means that this int is basically stored in t, so t means int, and now I can use t to create x, to be an integer. If I say here, for example, string, like std string, sorry, now I can do something like a.x equals with hello world. And I can write here I can output a.x and the new line. And now t here is a std string. And so this is extremely useful. So you see, for example, when you use arrays, for example, when you write std array, and in here you write the type of, you write, for example, int, or you can write double, and the vector as well. And now, so let me just explain like each word from this code, what it means. So template basically creates a template. Now type name, you can write here class as well. It is the exact same thing. However, type name is preferred because class is, you use class to create a class, and here class has a completely different meaning. You can just use type name. It's a bit longer, but it's better to use type name. It just looks better in my opinion. And now t is the name of so where you store this. For example, if you would call this name, here you would write name x, and it will be the same thing. This would run. And in general, when you use type name, you use t, because that's just common practice. Now we declared the class my class as usual, and here we use t instead of, so for example, I can now use I can also say int y, so this works as well. And so t basically just is a placeholder, I would say. And why I want to say that, because actually no, never mind it. Okay, so I think you understood until now. This shouldn't be that hard. And now I'm going to show another example where, so for example, let me just comment this out, and I can create a template, and instead of type name I can actually put here like an integer. For example, I can put int, and I will call it capital M, class my class. And actually there's no need to actually comment this out. I'm just gonna let it here, and I will call it my class to public. And now here I can store a number, so I can use this number. For example, if I want to create an array, I can use I will create a C-style array, because it's for example array and of n elements. And now here I can just create my class 2, and I can write something like 56 b. And now this will create an array with 56 elements, because so that's, now I can do something like b dot array of 6 equals with 3, and that's this cout array of b dot array of 6. And this will output 3. So this is how another way that you can use these templates. You can also put multiple arguments inside a template. So 1 second. You can use type name P, then you can write comma and int n, let's say, and then another type name S, for example. And I can use class my class. And now here I can do public. I can say, for example, T and array of n. So this is a C-style array of n elements of type T. Now I can do SX. So, and how am I going to, what am I going to do with this? I can create, for example, my class. Let's say that I want int 12 and char, and I will call this 8. And now I basically, here I basically have an array of 12 integers, because T is an integer and n is 12. And I have a char x, because s is char here. So I can do a.array of 6 equals with 5, and a.x equals with j, let's say. And this will work perfectly fine. Okay, so now you may ask why this is actually that useful. Why can't I just write here int and here char, or here 12 and here char? Well, the idea is that let's say that we want to create, let me just delete this. Let's say that we want to create our own array. Well, let's say we want to create an array, template type name T, and int n, class array, and public. Now just create the T and array n. Now we can create, for example, array of int and 6, array, and we can say char and 79, b, array and sd string, and I don't know, 299, for example. And so you can basically just create multiple ways, multiple types of this, or multiple different ways to do this class. And now I hope you understood this until now. And I'm going to explain what I meant at the beginning, that with templates we make the compiler write code for us. Well, let's take a look at the simple class. Let's say a template class, type name P, that creates a class, my class, and that my class has an object public and px. Well, what is now basically this my class doesn't actually exist right now, and it's just a template. Think of templates like at a blueprint, for example, at a blueprint of a class. And basically when you create my class int, now basically the compiler, I'm going to put down here what the compiler does. The compiler basically creates a class, my class, in the exact same that we did, public, and here int x. And I can say, so this is what the compiler creates after this template blueprint, I would say. Now, if for example we want to create my class of double b, now the compiler creates another class, my class. They have different names. I will just put my class to translate them. but it doesn't really matter. I will do public and double x. And in the same way, if I write my class of std_string, for example, here it will create another class. So class my class previous with public std_string x. So basically, this is just a blueprint that you give the compiler, and the compiler builds the class by itself. And this is the same as you just writing all these classes, but it's basically easier to just manage, if you want to change the code, if you want to add another thing here, let's say another integer in y, you will have to change it like in each class if you write each class by yourself. So int y, and int y. And this is really, first of all, why would you do this when you, it's a bit more complicated when you can just create a template for it and let the compiler do it for you. And the idea is that this doesn't actually take any kind of, like, it doesn't make your program slow or anything, because this is handled before the program actually starts running, and just the compiler does everything. Okay, and now you saw that I use the template class everywhere. However, you can also use templates on functions in the exact same way. For example, you can do template type t, and we can do a function. Let's say it returns t, and it basically adds two numbers, let's say, with two arguments, ta and tb. So everything is of type t here, and it returns a plus b. So this means that now I can just call the function add, let's say int, and now 4 and 6. And wait a second, and as we want to print this out. And now let's say that we want to do the same thing but with doubles. So we can do cout add with double, and 6.24 and 8.3. And for example, let's say that we want to concatenate two strings. So we can add, but here we will concatenate, because if you have a string plus another string, one second. If you have an std string plus another std string, for example, hello and plus word, this will give you hello world. I hope you know this. If not, you learn now. And so I'm basically going to do this exact same thing here. Std string and hello world, and a new line. Now if we run this, we are going to see it outputs 10, 4 plus 6 is 10, 6.24 plus 8.3 equals 14.54, and here it concatenated hello and world to make it hello world. So this is basically this is the basics of templates, and they can get extremely complicated, but you don't have to be scared of them. Okay, so now I'm going to talk about the friend keyword, and for this I'm going to need two classes, class A and class B. So when you declare a class's members as private or protected, but about protected I'm going to talk about in the next lecture. So if you declare, for example, private, and let's say int x, then you can't access this x from anywhere else outside of this class A. So if I try to do, for example, A, and let's give it a name, test. Now if I try to do test.x equals with 4, this will give me an error because x is private. But there is a way to actually like overrule this. And that is by declaring another class as a friend of class A. So for example, I can say that class B is a friend of class A, like to the friend class and the name of the class B. This means that now I can access the private members of class A inside class B. So I can do, for example, public. Let's say that here I want to do a function. It would be void print, and it will get an argument of type A and name A. This will basically do stdcout a.x. Also, let me just do some quick constructors here. So A and x of 0 and A with 1 constant int y, x and y. Okay. So let's say that we create test of 7. So here x is going to be equal with 7. Now we can actually print this from inside class B. So we just have to create an instance of the B class. Let's call it B. We can do b.print test. So this will print 7, and this means that we can actually access the private member x from inside class B, because B is a friend class of class A. And you have to keep in mind that this is not like this doesn't work both ways. So if B can access the private members of class A can access the private members of B, unless here you have like friend class A. So this is non-mutual. Yeah. So basically, if you would try here to do a function like void, let's say function, getting an instance of class B like this, and if you try to do B dot private int x, if you will try, for example, to do b.x equals 5, then this wouldn't work. I mean, it wouldn't work for a few reasons. One of them being forward declared the class. This means basically class B is declared after class A. So right now, over here, the compiler doesn't know that class B doesn't exist. Does exist, but I'm not going to talk about this right now. So yeah, this is going to run some more errors. Yeah, but anyway, the idea is that you can't access private members. The class A can't access private members from class B, because just class B is the friend of class A. Class A is not the friend of class B. You understand what I mean? So yeah, and in the same way, you can also create. Let me just get rid of this. You can also create functions that are friends of a class. We can create, for example, void print, like the same type of function, and just get rid of class B for now. Think void print A, and here I can do stdcout a.x, and here I can do friend, and I want to friend void print. So A like this, and one second, I forgot to change this. So now if I want to do print and test, this would also work because the function print is a friend of class A. So now I'm going to talk about the explicit keyword. And so let's take an example of a class with one member. Let's say int x. Now let's make some constructors. X 0 and a with a constant integer y x y. Okay, and now let's say that we have a function void func that takes a parameter that is a constant class a. So let's say a, and let's say that it outputs as this cout a.x. Now if I call this function, let's say that I call it func, so wait, let's say that I create a and I call it I don't know, f of 6. Now I can call this function using this f, right? And this should bring 6. Yes, as you can see. However, the C++ compiler can do one implicit conversion. And what does that mean? It means that, for example, if I have something like func and let's say 35, the compiler can actually convert this 35 to a class, so this integer, to a class with an integer member. So that means that it can actually convert 35 to a and be making a.x equals with 35. So if I do this, it is going to print out 35 because it calls this function, it converts implicitly a 35 to a dot, and then you basically have the a.x equals with 35. And this can actually lead to some errors and bugs if you don't pay attention to this. So what you can do is you can declare this constructor, that is the constructor that is being used when you create this object, because you basically create this object using a constructor, and because here you have an integer, you use this constructor that uses the integer. I know it may sound a little bit weird what's happening right now, but yeah, this constructor is being used when you create this object. So what you can do is you can declare this constructor as explicit. And so you just write the explicit keyword before it. And this means that the compiler cannot do any implicit conversion. So now this func35 should have an error, as you can see. No known conversion from integer to constant a. A is the function. So, and this basically makes your code more error prone, so you don't make that many errors. And because, as I said, this can be overlooked, and you can just end up with some weird result and you don't know why. And it was because of this conversion. So yeah, that's what the explicit keyword is used for. And now we are at the end of the lecture. I hope that you liked and that you learned something from it.